Can you hear me? Okay. So today is lecture number 2. So today we will go through signals and operations, and the readings is page 6 to 11. And as we know, on Monday it's going to be Martin Luther King holiday, so there will be no meeting. Then the next meeting will be on Wednesday, January 17th. So the readings page 11 to 21. And on Friday, the reading is page 16 to 21. And there's a homework one due, so make sure to do your homework. So the deadline will be Friday at 10 a.m. Make sure to submit the homework on Canvas as a PDF file. The homework is posted, so you can follow the directions about the homework, which is including, there's a PDF file, it's called homework 1, and there's a problem 111 in the textbook. As we know, the problem or the homework will be graded only in one problem, and we don't know yet which one. So the TA will choose a random problem, and he will grade it for the rest of the course, for the class. Lab 1 will be starting from next week. So the last 10 minutes of today's lecture, the TA will come here and will tell you more about the lab. So that's our plan. Okay, let's discuss, go to today's lecture. So last lecture we stopped at the continuous and discrete time. So if I give me a small demonstration here. This is x of t for the signal, and this is the time. And let's assume the waveform is like this one. This is the waveform of the signal, which is x of t. Then, for the discrete time, this is continuous time, which is changing with time. And let's assume this is the time, for example, 3 seconds, this is 2 seconds, 1 second, here is 0, here is -1, -2, and here is -3. And let's assume we need to do a discrete time by assuming the time step t as 1 second, or in other words, we can say t0 or delta t, whatever we can call it. We can call it like this. Therefore, in discrete, you cannot choose any time you want. So you are limited within time frame, like one second. Just that's it. So basically, we can say like t equal n t0. That's the time that you can find, such that you can say x of n equals x of n t0. That's the only thing that you can do. Such that n can be -3, -2, -1, etc. 0, 1, 2, 3, and so on. It must be, n must be integer. So in discrete time, you have only access to choose only a time, an integer time. And since we have TO equal to 1 second and an integer, so the only options that we have, like x of, for example, 0 equal x of 0 times 1, which is 0. X of 1 equal x of 1 second, 0 second, 1 second. Because 1 times 1, 1 second. Then x of 2 equal x of 2 seconds. X of 3, the same thing, x of 3 seconds, and so on. And the same thing for the negative number. X of -1 equal x of 1 second, x of negative 2, x of negative 2 seconds. So if the time step here is 1 second, then that's what we can do. But if the time step is, for example, half second, then you can go step halves, like x of 0.1, 0.5, x of points, x of 1, x 1.5, or negative 0.5, and so on. So depending on the time step. So we are very limited only with the time step to determine how we can go. Then in the waveform, how's the behavior of the time step will be? It is going to be, for example, like this. So at 3 seconds, it's already been 0. At negative 3, 0. At negative 2, it will be like this. Like this way. At 1 second, or negative 1 second, and t equals 0. So basically, so this is called x of n. In other words, if I want to redraw x of n, let me redraw it here in a small graph. It will look like this. This is x of n. So you see x of time is in red shape, x of n is in the green shape. So that's how the discrete will look like. Then the things which is about the discrete depending on the time step. If the time step is big, then we don't have complete information about it. So in other words, this shape, if you need to connect this, link these two, three, let me do it here. From here, this way. So if you want to link them, the waveform will look like this, small shape. In other words, it will look like this way, if you want to make it back continuous. So this waveform does not the same as, it's not the same as this one, the organ. So what does this mean? This means sometimes when you make discretization the system, if you have a low step size, this will make what? Will make the system or the information incomplete. Then if you need to let it go back to continuous, it will still have some missing information. That's sometimes in other words, we can call it like resolution. The resolution will not be accurate. So the step size, that we call it TO or delta T, this is something I would say related to something called frequency. So the higher frequency, the lower step size, or the higher resolution, the lower step size. So that's why when we have a higher resolution, you will have a clear image. Then if you have a low resolution, you will have a distorted image. You can call that by looking at the image, like when you look at videos, or even like a regular image, like SD quality, HD quality, full HD, 2K, 4K. So why, when you look at image with 4K and image with SD quality, of course you will notice the difference. Why? Because the resolution of 4K is better than the resolution of SD. And here the time sampling, or delta T or T0, this is an example of resolution. So if we have 1 second resolution, poor quality. If we have 1 millisecond, this is better. If you have 1 microsecond, this is even better. So the lower time is the best, while the frequency is 1 over the time. Therefore, the higher frequency, the lower the time, then the best. Okay? Clear? Okay, perfect. Now, let's go discuss a little bit about the system properties. So there's one of the system properties, it's called causal system. Causal system means inputs causes outputs. For any system that we have, by the definition, we have inputs, x of t, then we will have outputs, y of t. So for any causal system, the input must causes outputs. to be considered as causal, which means, in other words, the output depends on the present or past inputs. So I will say that the output y of t depends on past or current input values. Which is x of t. If we realize that if y of t depends on future value, future input values, then it is not causal. Okay? So in order to consider this system is a causal, it must be depending on the present or the past. While the future, if it's depending on the future, then it's not causal. In real life, there is nothing such as called non-causal system. There is no application at all for non-causal system because we cannot predict the future. We don't know what's going to happen in the future. So I would say that any real system is causal. While sometimes we can make some mathematics expressions that have non-causal, but this is unrealistic. So basically, it will not participate, it will not or anticipate about the future. We cannot predict the future, we don't know what will happen to the future, so no system, no real life system is not causal. Now there is something else also, another property is called memory system. So memory system, if the system depending on, or I would say, output depends on past or future inputs. That's we can so call memory system. It has a memory list. While there's something like memoryless system, output depends only present inputs. Depends only on present inputs. So that's it. Memory, there is something depending on past or future, while memoryless, there is no memory on it, so depending on the present. Okay, so these are very basic definitions. Very clear. Now, I would like to discuss something called time variant and time invariant systems. What do I mean by each? Time variant, or I would say like time invariant first, then I would say time invariant. So time invariant means that system responds to the inputs does not change with time. And time invariant, I used to make a shortcut as TI, time invariant. Then, how about time variant? Time variant, which is TV, system response to the inputs change with time. Means there's something happening with the system that's changing with time. Likewise, what's an example of time variant, time invariance? As an example for time variance, time invariance, which does not change with time, like the microphone. So if I speak loudly, then you'll hear me loudly. If I speak normal, you'll hear me normal. So that's fine. The system will not change depending on the input, which is my voice. Then you can hear it through the speakers. There's no change in the system. Or like when you drive a car and make a cruise control. So if you press inputs, increase the inputs to go to 70 miles per hour, or actually it will set your target 70 miles per hour. It will go through it. Autopilot as well. The system does not change. The system as is. So no change at all. If I'm driving during the night, driving during the day, that's fine. At any time, that's fine. Even when, also, like the speakers, during the daytime, there is no change in it. Like another example, or an example of time variance, like one example, like our rockets. Like the rocket, when the rocket goes to the space, it's consumed a large amount of fuel. So which should affect on the mass. Also, the mass will be changed in a small time, in a very short period of time. And even when the rocket goes, it will be like a huge mass. Then when it goes up, a lot of fuel consumption, and even some part will be disconnected. This change, the system is changing, right? The rocket is changing. So when it goes reach the space, it's not the same mass or not the same component as when it was in the ground. So it's changing with time. So this is considered as time variant. Or anything with aging, something changing with time, is also time variant. Or you can say like, even like our bodies with time, but for large period of time, it's changing, we are growing. It's not like us changing, or not like we get old. So this is time varying. So when the system itself is changing with time, this is time varying. While if everything is the same, as I mentioned, like the speaker, cruise control, we are pressing cruise control in the morning, or in the afternoon, the day, the night, it's still cruise control. There is no change. Right? So that's how we realize between them. Now, when we look at the mathematical model, how can we check if this one time variant or time invariant by just looking at the mathematical model? So here is the question, which is check time invariance if the system is time invariant. So that's our check. If it is not time invariant, then definitely it will be time variance. So it can be either on or off. So Ti or T. So basically, when you have x of t, it should give you y of t. So the question is, when you apply x of t minus to, will it give you y t minus to? If yes, then it will be time invariance. So how can we achieve this? We need to apply two tests. The first test, replace every t by t minus to. The second test, replace every x of t by x of t minus to. Then, if the result in 1 equal the result in 2, then if yes, it is time invariant. If no, then it is time variant. Okay, this is the procedure. How? We will go now to some examples so that you can have a clear picture. Now, example. We have y of t equals to x of t plus 2xt minus 1. This is the system that we have. Now we need to check the first thing. Is it causal or non-causal? Causal means, is the input depending or the output depending on the presence or past inputs. Here's present, here is past. Then yes, it is causal, right? Now, is it memory or memoryless? Is it depending only on the present or depending on the past and future? We have some past inputs, right? X of t minus 1, right? Past inputs. Therefore, it is memory. Because again, it is depending, one of them depending on the past inputs. Okay? Now the last thing, which is we need to check, is it time variant or time invariant? So let's apply the first thing, which is replacing t by t minus t0. So it will be as, the equation will be as x of t minus t0 plus 2x of t minus t0. Now the next thing, replace every x of t by x of t minus t0. Then let's replace them. It will be as x of t minus t0 plus 2x of t minus t0, and we have 1 minus 1. I think I forgot this here too. Minus 1. Then by looking at equation 1 and equation 2, they are equal to each other. Therefore, it is time invariant. It is time invariant. So the first step, I replaced every t by t minus to. The second step, I replaced every x by x of t minus to. Okay? Does this make sense? Okay, let's have another example so you can see which is y of t equals to t plus 1 times x of t. Now, the first question, is this causal? Look at the inputs, x of t, depending on the presence inputs. So is it causal? Yes. So it's causal. Now, is it memory or memoryless? What do you think? Is it depending on the future or past inputs? No. So it's memoryless. Memoryless. Now the third thing, which is to check, is it time variant or time invariant? Substitute every t by t minus t0. So it will be as t minus t0 plus 1 times x of t minus t0. This is equation 1. The second test, which is replace every x of t by x of t minus t0. So it will be t plus 1, every x of t will be x of t minus t0. Now, does equation 1 equal to equation 2? No. Therefore, it is time variant. Okay? So these examples of time variant, time invariant. Now, a third example. Y of t equals to x 2t minus 1 plus 2. So is it causal or non-causal? Does this depend on the future input output or not? So let's substitute, for example, y of 3. Y of 3 will be x of 2 times 3, 6 minus 1, 5. X of 5 plus 2. So y of 3 depending on x of 5. So depending on the future. Therefore, of course, it's going to be non-causal, right? It's not causal, non-causal. Did you get it? Substitute t equal 3, then realize it's depending on the future. So it's non-closable. Then the other thing, which is it memory or memory list? It's memory, of course, because it's depending on either the future or the past. Then the third thing, which is check apply the test, which is substitute t minus t0, so which is going to be x of 2 t minus t0 minus 1 plus 2, and the other thing, replace x of t by x of t minus t0, so it's going to be as x of 2t minus 20 minus 1 plus 2. These two are not equal to each other, therefore it is time variance. Because here 2t minus 20, while here 2t minus 20. So 2 was between brackets, but now the other one is not between brackets. Okay? Therefore it's time variance. It's not time variance. Any question? Okay, let's go for operations and signals. It's going to be trivial and we'll know it. Which is the first one, which is the signal sum. So if we have x of t plus y of t equals to, for example, to z of t, how the system will behave? Let's assume we have x of t signal like this. And I'm going to also plot y of t, and I will plot z of t. And here is x of t. So I'm going to assume x of t as shown here. Then I'm going to assume y of t like this. Make guidelines. Then let me put the values. So this value is 2, this value is 2, and I'm going to assume here some guidelines like so these values 1, I'm going to make another guideline here. Value is 1, again this is 2, and I need to write the values of the time, the corresponding time. So I'm going to assume this is 0.5 second, this is 1 second, 1.52, here is 2.5, 3 seconds. So here's time, and our target is to make their sum. So z of t, which is x of t plus y of t. Now, we can make the sum easy. So when the time is 0 and below than 0, 0 plus 0, let's look at this part. 0 plus 0, 0, so everything will be zeros. Here. Now look at the time between 0 and 0.5. 0 and 0.5 here is growing, this is 0. So the slope will be the same slope. Then it will go from 0 to 0.5, it will reach 1. So this is again 0.5, here is 1, 1.5, here is 2, 2.5, 3. So it will reach the value 1. Because like x of t. Now do the other sum, which is we have here, it's still growing, so it will reach 2, while the green, which is y of t, is 0. So it will keep growing until reaching 2. Then after between 1 and 1.5, 1 and 1.5, they are the same slope, one of them going down, one of them going up, so they will cancel each other. So if the slope is -1, the slope is +1, the slope is 0, slope 0 means constant, so it will be constant. Maintain this value. Then between 1.5 and 2, this goes down, this goes up, so also they're canceling each other, so the slope will be 0, so it will be maintained constant. Then between 2 and 2.5, here, this one is constant, this one is negative, therefore it will be a negative slope. And it will reach to 1, because 0, here you have 0 plus 1, 1. So it will reach to 1. Then, next, here slope is 0, slope is -1, then at point 3, 0 plus 0 is 0, so it will reach 0. Therefore, it will go back to 0. Then after 3, 0 plus 0 is 0, then it will go to 0. So like this. Okay? Clear? So you see, it's simple, it's just like some graphical representation. The second thing is related to scaling. Constant times signal. So y of t equals a times x of t. So here in this scaling, let's assume we have this signal as here is t, and this is 1, here is 1, 2, here is 0. Then let's assume that y of t equals 2x of t. So what will happen for the scale? Here is x of t. So it will be just double the size. So the x-axis does not change, it will remain 1, 2, or the t-axis does not change. While what will change is the scale. Okay? How about if I assume a negative value, like if I assume y of t equal to negative x of t. So what will happen? Just keep in mind to flip them. Here is t. So there is no change on the x-axis. The change on the t-axis, the change only as the y-axis. So here is 0, here is 0, then 1 times -1 times -1, it will be -1. So it will reach to -1. Then okay? Does this make sense? So this is called time scale. And the other thing, which is multiplication of signals. Signals times signals. So z of t equals x of t times y of t. So let's assume this is x and assume y assume then z. I prefer to make the guidelines the guidelines will be divided here. So let's use time 0, 0.5, 1, 1.5, 2. So the guidelines for 0.5, guidelines for 1, guidelines for 1.5, guidelines for 2. Then, let me plot the waveform as an example. Here it will go to 1, 0 and 0, here was 0, so this is 1. The other one is at 0.5, it will go here, so it was 0, then it will reach 1. Now my target is to make the multiplication. So the multiplication, initially, with t less than 0, everything will be 0, right? 0 times 0, 0. So it is 0. Then, what will happen, which is at this area with 1, 0 and 0.5, it goes up, but times 0. Times 0 is 0. So it will remain 0 because everything times 0 will be 0. Then, with 1, we need to multiply this with 1. Anything multiplied with 1, even not only with this one, look at overall waveform. Anything multiplied with 1, the same thing, x times 1, x. So you just copy x, what's inside x. So what will happen, it will jump. Here I think that's 0.5, it is 0.5, so at 0.5 it will jump directly to 0.5, then we'll copy what will happen with x. Here, 1, then it will back to 0. So again, when we write them, it is 2, 1.5, 1.5, okay? So you see how the waveform look like because we did the multiplication. And of course, if it is more complicated waveform, very similar way, but the overall concept that I do, any change make a guideline. So when you make a guidelines, it will be easier for you to do the graphical. Now there is also time shifts. This is related to signals transformation. Signals transformation, time shifts. So let's assume we have this signal that goes from the origin, which is x of t equal to t. Okay? So here is the origin, here is 1, here is 1, here is 2, something like that. However, time shifts, if we used x of t, or if you assume, y of t equal to x of t minus 2, this means 2t minus 2. So what will happen in the time shift? You will look at the time shift here. It is t minus 2. Make it equal to 0. So t equal to, therefore, means delay by 2. Or shift right by 2. So we will shift right by 2. It was at 0. Now it will be at 2. Because shift right by 2. 1, 2. So here y of t equal x of t minus 2. Okay? Because we make it shift right. How about if I assume z of t equal x of t plus 2. In other words, 2t plus 2. So what will happen? Basically, look what's inside the brackets. You will say t plus 2 equals 0. Therefore, t equal minus 2. This means you will shift left, since it's negative, shift left. If it is positive, shift right. If it is negative, shift left. So what will happen to z? Here is negative 1, here is negative 2. So you will go 2 steps, from 0 to 1 to 2, which is the negative 2 here. So this is z of t, which is x of t plus t. Okay? So in general, when you have any x of t plus b, then it will be t equal minus b, means shift left. If you have x of t minus b, or let me say minus c, therefore t will be c, which is positive, therefore shift right. So shift left if it is negative, shift right if it is positive. That's it. Okay? Is this clear? Now another property is called time scaling. Time scaling, if we have x of at, depending on a, if a larger than 1, then you will shrink the waveform. If a less than 1, you will expand. Okay, so what do I mean by shrinking and expanding? Let's see what's this waveform. And I'm going to assume here is 0, here is 4, here is 2, 4, 6, and 8. So I'm going to assume x of t as goes to 4, then back at 8, like this way. This is x of t. If I say x of 2t, x of 2t, if it is larger than 1, then you will shrink. And 2t shrink the double. So what will happen? And the peak, what used to be at 4, since it shrinks, it will be 2 divided by 2. So the peak will be at 2. So then it will go back to 4, and it will be 0. So here is x of 2t. If I need to say, how about x of t over 2, then you will expand it twice. So by expanding it twice, it will be as, it will reach the peak at 8. Then it will keep going until reaching 16. Okay? So, it's depending on if the factor larger than 1 or lower than 1. Any question? Okay, let me start today's lecture so we can go with the TA about the lab.
Hi everyone, my name is Xuan Wang, and I will be your TA, one of your TA, and I will be responsible for 3 sections. For your lab, there are 2 kinds of labs, the MATLAB lab and the TMS lab. The MATLAB lab is online. We will send you a Zoom link, you just access to the Zoom link. And the TIMS is in person. You should come to the classroom. and the tendency of the in-person class is required, but for the MATLAB it's not. If you don't have any question about your code and report, the document, you don't need to attend the online the Zoom link. Let's see So for now, you can open your cameras and go to the file and lab. You will see the schedule file here. So in our lab classroom, we have 8 desks, but 2 of them are broken now, so we only have 6 available. That's why we will divide you into 2 groups, the blue group and orange group. And each group will have 6 students. And here is the assignment. You can check the schedule and make sure your name is in this file. If you can't find your name in this file, just send me an email or send me a message by Canvas as soon as possible. So here is our time and our classroom and the TA name and the Zoom link here. This is a whole schedule of all the semesters. So for this week is first week we don't have a lab. For next week we will start your lab 1 and lab 2. The blue team will do lab 1 and the orange team will do lab 2. The lab 2 is in person and lab 1 is online. So just make sure you know which group you are and know the time of the lab. Don't miss the in-person labs because we don't have enough available machine in our classroom. So if you miss your in-person lab, it is difficult to make up. So just make sure don't miss the in-person lab. And for the third week, the blue team do lab 2 and orange team do the lab 1. And okay. So for the report requirement. This is a report requirement. The report should be a website. I gave you an example here. So there is an example of your report. So your report should be a website, and so for example, this is a lab 1. Can open it, and this is the web page of lab 1. It should answer the problem of your lab 1. Because in your lab, for example, here, so for each lab we have just 2 files. This one is for me, and one file is a process of your lab. You just read this document and do the experiment step by step. Just follow this document. And this file named answer sheet lists all the questions you should answer. I will grade your lab rely on the answer sheet. Just to make sure you list all the answers of your answer sheet. So you should answer each problem and list the answer here. And if the answer sheet or the document asks you to do a screenshot, you just do the screenshot and post on your web page. And so for the MATLAB, you should post your code on your web page. The screenshot TXT file or MATLAB file is all acceptable. A screenshot is alright for me. Just to make sure I can see your code, I can see your result. So the width doesn't matter, just to make sure I can see your code and result. Don't miss your code because I will grade your report rely on your MATLAB code. Okay, so for here, you can use this kind of website to make your own web page. Just to select one. Okay, that's all.
Any questions?
Final sentence. I already uploaded this file here. You can just open this file and dump the report here.
Thank you so much. See you on Wednesday.